Okay, we are moving from chapter 4 back to chapter 2. The homework set this week will cover material that's addressed in exercise set 2C and 3A. So the first set of chapter 3. Those two go very close together. It's all about truth tables. Exercise 3A just asks you a question about the truth tables. If you were in class, you saw that's the question about whether the proposition is a contingency, tautology, or contradiction. So those two sets go together. So we're just combining truth tables, and then we're going to move on to some applications of truth tables and some additional logical concepts. So for this video, we're going to work exercises. Exercise 2C and 3A. They go together. So we'll work these propositions in 2C, we'll make truth tables for them, and we'll ask what kind of proposition they are. Okay, let's just work them in order here. First one is P and Q or P and not Q. P and Q or P and not Q. And I mentioned in class the reason he uses P's and Q's is to show us one of the applications here. P and Q's are letters we use to stand in for pretty much any proposition. So any proposition of this form is going to have this truth table. You have a conjunction with an or in the middle, another conjunction where one of the statements is negated. A little more complicated with this, you can see this, you could substitute even compound propositions for P. Okay, but what does the truth table look like for this propositional statement? You have two distinct capital letters, P and Q. So you're going to have 4 rows, 2 letters, 4 rows, 1 letter, 2 rows, 2 letter, 4 rows, 3 letters, 8 rows, and so on. Your method here is to alternate truth values in these rows for Q. The right-hand column. So we go true, false, and then we go 2 and 2 in the left-hand column. True, true, false, false. If you want to go left to right, I think go half and half in the left-hand column, 2 and 2, and then right, you divide that, right, from 2 to 1. Okay, true, true, false, false, true, false, true, false. These are our 4 scenarios. We're asking you, what's the truth value of this compound proposition in each of these 4 scenarios? All right, so how are we going to break down this this proposition? We're going to look at the connectors. We have this conjunction, this and connects P and Q. So the letter we have under this and is going to give us the truth value of this proposition. You come over here, we have this and proposition, we have not Q. So the letter we put under this not sign gives us the truth value for this unit, not Q. Then under this and will be the truth value of this whole statement. And this is the main connector that connects this conjunction with this conjunction. And so what we have under here will be the truth value of the whole proposition in these different scenarios. So scenario 1, both P and Q are true. Scenario 1, both P and Q are true. Okay? Since they're both true, this conjunction is true. Right? We can work it simply in this order. 1, 2, 3, and 4. Since Q is true, not Q is false. Okay, since Q is true, not Q is false, so this conjunction is false. True and false equals false. So we've got true on this side of the or and false on this side of the or, so the whole or statement is true, since this half is true. All right, when P is true but Q is false, this conjunction is false, but we come over here, P is true. Since Q is false, not Q is true, and we get true and true, which is true. And so these are the two halves of the OR statement. One of them is true, so the whole OR statement is true. And if you look at the larger statement, this should make sense. The larger statement says either P and Q are both true, or P and not Q are both true, right? And so it sort of says either way P is true. So when P is true, this whole statement's going to turn out to be true. But when P is false, we've got false, true over here. So the AND statement is false. Q is true, so not Q is false. P is false, so we get false and false is false. And again, that gives us a false statement under our main connector, false or false. Okay, how about when both are false? This conjunction is false. Since Q is false, not Q is true, but P is false, so again, this conjunction is false. So we've got false or false equals false. Okay, so this proposition is true when P is true, regardless of Q, and it's false when P is false, regardless of Q. Okay. This proposition is actually logically equivalent to simply the proposition P. It's true whenever P is true, false whenever P is false. Okay. So, what do we need for these truth tables? We need to figure out the number of rows we need, the number of scenarios, which we figure out by how many distinct capital letters we have. We need to set it up properly, and then we need to understand the syntax of our proposition and the order in which we need to work these connectors. We worked on that in chapter 2. You see, each of these rows, I said this in class, each of these rows is like what we did for the first set of chapter 2, right? When you take P and Q to both be true. Then you do another one. What if you take P to be true and Q false? But you're just working those branching, right? That branching method we use to determine truth values. You're determining the truth value of the whole statement when you have the truth value of the capital letters. Okay, and we'll get practiced at that. This main connector column gives us the truth conditions of this whole proposition. Under these circumstances, it's true. Under these circumstances, it's false. And since you have a mix of trues and falses, this proposition can be true sometimes, depending on the truth value of P and Q. Other times false. We call this a contingency. You have a mix of true and false in the main connector column. So we call this proposition of contingency. Whether it's true or false depends on the truth value of the parts. Okay. That's number 1. Let's do number 2. I'm going to be able to keep this for several of them, so I'll just keep this set up. Actually, this one just has P, so we don't need P and Q. Let's leave this on the side, but it's not here for number 2. For number 2, we've got not P and parentheses, not parentheses P and not P. Okay? So we have P and not P in parentheses, but we have that whole statement negated. We only have one capital letter, one distinct capital letter, so we only have 2 rows. True, false. Now, whatever you can do in your head, I want you, when you're writing your truth tables on your homework, you're going to have to construct these truth tables like you're asked to in exercise set C and answer whether the proposition is a contingency, tautology, or contradiction, which you'll determine by looking at the truth table. So I don't want you to take shortcuts in the truth table. A, it helps me see your work and understanding. It helps me assign partial credit. And I will take off if you're missing some of the work, if you did some things in your head. If you do real quickly in your head, not P, and don't write it in here, and so you just write false here, I want to see that's a shortcut, okay? Under every connector, I want you to work the connectors in order. In this case, right, you have to look at this negation before you determine the truth value of this AND statement, and you need the truth value of this whole statement before you can determine the truth value of this. So I want to see filled out columns under this negation, under this AND, and under this negation, under every connector. Okay. Since P is true, not P is false. This is row 1. Okay, scenario 1. So we get true and false, which is false, but then that's negated, so the whole statement is true. Likewise, when P is false, not P is true. P is false, so we get false and true, which again is false, because this, inside the parentheses, is a contradiction. When we negate it, it's true, no matter what, and so we call this a tautology. Okay. Every proposition has a negation, right? Every proposition has its opposite, right? A and not A are opposites. Indeed, you could write A as not A, the negation of not A. Okay? A and not A are opposites. They have the opposite truth value. Take any of these propositions, you can throw a negation sign in front of it, and they'll have opposite truth values. Okay, why am I saying that? Because look, the negation of a contradiction is a tautology. The negation of a tautology, if you say a tautology is false, which is true no matter what, is a contradiction. It's going to be false no matter what. And the negation of a contingency is going to be another contingency. Here's something that's true sometimes and false sometimes. The negation of that is also going to be true sometimes and false sometimes. Indeed, it's going to be true when the other's false and false when the other's true. Okay? All right. This is a tautology. It negates a contradiction. Okay. Number 3 negates a tautology. So we just have to make some slight changes here. The setup's going to be basically the same. The proposition is not P, not parentheses P, or not P. Okay, that changed. The order is going to be the same. The structure is very similar, but so I've kept our setup here. When P is true, not P is false. When P is false, not P is true. But here we get T or F, which is true, and F or T, which is true. And so each time when we negate it, it turns out false. So here we have the negation of a tautology, which is a contradiction. False in every row. False in every scenario. False no matter what. All right, let's work a couple more. Let's work number number 14. Help us look at arrows, couple connectors, and give us a sense of how this can work. Okay, 14. P or Q in parentheses is equivalent if and only if, we got the double arrow, we got to talk about that, not P implies Q. Not P implies Q. Okay. This is going to be our setup. We got P and Q. All right, we have P or Q, right? Our order is going to be this. We can work the left side. You have to determine this negation before you deal with this arrow statement, and then you have to do all 3 of those before you deal with the main connector, which is this double arrow. Remember, the double arrow means same truth value. So if the left side has the same truth value as this right side, we're going to put true with the double arrow. If they have opposite truth values, we put false. Okay. P or Q is a straightforward one. We know how that goes, right? True, 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 and false. Okay. We come over here. When P is true, not P is false. So we have false arrow true, which is true. When P is true, not P is false. So we have false arrow false, which is true. When P is false, not P is true. Okay. So when Q is true, we have true arrow true, which is true. And when they're both false, not P is true, but Q is false, and so our arrow statement is false. These are indeed logically equivalent expressions. They always have the same truth value. Remember I told you that the or equals not arrow, and we can see that that's been done here. So not only will these sometimes have the same truth value, they always have the same truth value. So this double arrow statement, are they equivalent in row 1? Yes. Are they equivalent in row 2? Yes. Are they equivalent in row 3? Yes. Are they equivalent in row 4? Yes. They both have the same truth value. Okay, so this statement is a tautology. Okay, it's a more complex tautology than we've seen, but it is a tautology. Pardon me here. I think the video's still going, but my computer went into the home screen. But last time that happened, it kept recording. Okay, let's look. Number 15 has some similar features here. We don't have the double arrow. Work number 15. And then that'll give you enough to go on, and we'll see where we are Monday and see if we need additional material. Number 15. Not parentheses P or parentheses P and Q. No, sorry, P arrow Q. All right, now he uses double parentheses here. I actually like to make these outer parentheses brackets so you can see the structure. Okay, we've got P arrow Q in parentheses, and we've got this larger statement, P or P arrow Q, and then we have that whole thing negated. Okay, so our order is going to be, we have to figure out this arrow statement within this inner parentheses to figure out the truth value of this larger statement, P or this, okay, and then we negate it. Now let's think about P or P implies Q for a second. All right, when P is true, this whole statement's going to be true because it's an or statement. Right, now when P is false, this statement's going to be true, right? Because a false antecedent always makes a true statement, right? So this is a pretty good statement, but we negate it. So let's see what happens. All right. P is true, Q is true. P implies Q is true. Both halves are true. We negate this whole statement. Negate this to get F. Okay. How about when P is true, Q is false? Okay. We have true arrow false, which is false, but P is true. So we have true or false, which is true. But again, we negate it, and we get a false statement. How about row 3? P is false. Well, we know that's going to make P arrow Q true. Because a false antecedent, false arrow true is true. So we have false or true equals true. But again, we negate it. So the whole statement's false. And finally, when both P and Q are false, we have false arrow false, which is true. P is false, but we get false or true. Right? Anytime P is false, this is going to be true. And when P is true, this whole statement's going to be true regardless here. And again, we negate it. So the whole statement is false. Again, we negated a tautology and got a contradiction. Negated a tautology and got a contradiction. Okay. That's several of these. This is all you're doing. I've combined what you're asked in exercise set 3A, which is just to state whether the proposition is a tautology, contradiction, or contingency. Right? That's all you add to exercise set 2C. So your exercises are set 2C plus this question, is the proposition a contingency, tautology, or contradiction? All right, that's truth tables. Remember how you set them up. If you have 2 distinct capital letters, it's going to be 4 rows. 1 distinct capital letter, it's going to be 2 rows. 3 distinct capital letters, and I don't think in the exercise you have more than that. 3 distinct capital letters is going to be 8 rows. We discussed this in class, so let me set that up because you will have that on your homework. I won't work one because it's going to make the video too long. We'll just do the setup. You have a statement like P and Q or R. You've got 3 letters, P, Q, R. You need 8 rows. Again, alternate on the right side column. True, false, true, false, true, false, true, false. Then double it. You go 2 and 2. And again, the left-hand column is going to be half and half. Double it again to get 4, which gives you true, 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 false, 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 false. And if you see here, like with the 4 row, you start the top row is going to be all true if you follow this method. The bottom is going to be all false, and indeed, each of the rows are distinct. P and Q are true, and R is false. True, false, true. True, false, false. False, true, true. Right? None of them overlap. If you erase this third column, right? If you ignore this third column, right? You have repeats in Q and R, both true, true, false, true. But between 1 and 5, P is true here, but false here, right? So you have variation. You have 8 scenarios. Each distinct capital letters doubles the total number of scenarios. Okay, and then you would work this the same way, right? Q or R, you look over here, you just work Q or R. You could work it down the column here, and then you can compare this with the truth value of this using the AND rule. Okay, let's call it. So you have this practice video, and we will follow up on Monday.